Fundamental Theorem of Calculus, Part 2. So in the previous videos, we've talked about the first part of the Fundamental Theorem of Calculus, which allows you to take the derivative of an integral. Now we're going to talk about the more computational portion of the Fundamental Theorem of Calculus, and this is something we've already been working with. So if f is continuous on an interval a to b, and f is any antiderivative, then the function on a to b, then you get that the integral from a to b of f of x dx equals capital F of b minus capital F of a. This simply means you take the antiderivative, you plug in the b value, you take the antiderivative, plug in the a value, and then subtract them. This allows us to evaluate definite integrals directly from their antiderivatives. This will apply for any integral. This eliminates the need for us to graph and find the area under curves unless it's a very complicated function. So in example 5, we're going to use the Fundamental Theorem of Calculus Part 2 to evaluate this integral. So here we go. We have the integral from -1 to 3 of x cubed plus 1 dx. So the antiderivative of this will be x to the 4th divided by 4 plus x from the interval -1 to 3. Again, this became x to the 4th over 4 because it used to be a 3. The power used to be a 3. So you raise it 1 power and divide by the new power. So now you solve this by taking the upper limit, which is b, and substituting it in for x. So you get 3 to the 4th divided by 4 plus 3, and subtracting it from the antiderivatives evaluated at point A, which is -1. So -1 to the 4th over 4 plus a -1. And then we just work that out. We're going to get 81 over 4 plus 3 minus 1/4 minus 1. Now I can lose my brackets, distributing the negative. So I get 80 over 4 plus 4, which is 20 over 4 plus 4, whoops, just 20, not 20 over 4, which equals 24. And that's all there is to it, to evaluating an integral. So what I want you to do now is work out these two integrals on your own. Here we go. Let's see if we got it right. So the integral of x cubed plus x from 0 to 1. So when you integrate, you should get x to the 4th divided by 4 plus x squared over 2 from 0 to 1. So we're going to get 1/4 plus 1/2 minus 0/4 plus 0/2. This whole thing becomes 0. And you get 1/4 plus 1/2, which is equal to 3/4. Alright, now let's work out the next integral. We're going to do that one over here. So when we integrate this, it's going to become x cubed over 3, but then there's a 3 in the numerator, so you're going to get 3x cubed over 3 plus 2x squared over 2 from -1 to 2, which is equivalent to writing x cubed plus x squared from -1 to 2. So you get 2 cubed plus 2 squared minus -1 cubed plus -1 squared. 8 plus 4 minus -1 plus 1. And your answer should be, whoops,